Feel better, Caleb. All right, Mr. Walker, we're sorry that you're not here with us. There's your homework, and yes, that looks ridiculous. But if we get as far as I would like to get today, we will be done with Chapter 5, actually. Tomorrow's going to be work day, but realize 5.7 and 5.8 both have like 11 questions. They're pretty easy. So 5.6, we're going to finish talking about trapezoids and kites. And then 5, 7, and 8, we talk about coordinate geometry, and it's pretty straightforward stuff. We did some coordinate geometry work in Math 1, so that's just kind of a continuation off of that. So, to dive in, first off, we wanted to talk about our Schoology page. My transfer finally went through, and the Schoology page is live. Now, because our page ends up having so much going on, I put our class materials actually into a subfolder. So you'll see you're on the materials page. I'm gonna, if I can, I haven't been able to figure out how to change the restrictions, but I want our page to land on the updates page, so if I ever post like a message, you would see it. If I can't make that happen, anytime you log in and there's a little box with a 1 or something next to the updates or next to gradebook, that tells you something new has happened. Up here tells you that somebody has sent you something or you have something due, or like these are like your notifications, like if you have a Facebook or whatever.
And then they don't go away. So
well, if you click on it and then then it goes away.
See, for me,
all you have to do is click on it and view it. I don't know.
And then
maybe you have to like clear it or something.
I ended up having 76.
Yeah.
I ended up having 76 notifications at one time, and then one of my friends was bugging me so much.
Yeah.
Just click on the little.
So, like for Caleb, which this is ironic because I'm gonna right now tell him how to find the video in the video. So he's probably gonna find the video from the YouTube channel. But let's say you're absent. You go to class materials by chapter, and we're on chapter 5, and here's all your chapters for the year. And then more stuff. We don't really have a chapter where the unit circle fits in. And then once we move beyond a chapter, I'm going to drop them in here. So every time you come to this page, you see the most recent chapter. And then these, as I add more content, will get bigger. But I didn't want it to like kind of blow you away to begin with. So I left these as just the folders, whereas this has that nice flowchart that we looked at yesterday. So if you click anywhere in there, you can get into here. You have the notes. These are all the blank copies of the notes. So 5.1, 5.2, 5.3, 5.4, come on. 5.3, 5.4, 5.5, 5.6, 5.7, and 8. And then back out in here, we have the homework if you don't have your PDF with you. However, I have uploaded all of the G PDFs. I need to upload the K PDFs because sometimes we do the G, sometimes we do the K. And then all of our videos from class are just here, embedded links from YouTube. So then you can get to it if you want to watch it straight on YouTube. Click on the little YouTube button and navigate straight to the YouTube page. Back on our main page, other things to look at is there's a Help Me folder. So as you guys ask questions and have issues and I make videos to help you. And then a Wow, That's Pretty Cool folder, which I'm trying to think of a better name. But this is just cool stuff that people have either sent me or I have found. So this guy's really sweet. His channel is called Smarter Every Day. He does one about how do cats land on their feet, and he does slow-mo.
The backwards bicycle, is that where he like makes it where you turn the handle?
Yeah, if you turn right, it goes left. If you it's,
oh my gosh, I watched that.
Yeah, so then there's like How Big is Infinity? This is really sweet that we'll probably watch at some point this year, The Great Math Mystery. And then How Ridiculous is a new channel that I've kind of gotten interested in. And they show that how a watermelon can actually survive being dropped from 45 meters up. So if you're curious about that, and then this is just awesome. This dude made a marble machine that plays its own music. So this is the video introing the fact that it was done, and then this is the video of it actually playing the song that he wrote for the machine. So if you want to check that stuff out, it's all there available to you. If you find cool stuff that you think should go here, email it to me, and I will post it here. Any other questions about our Schoology page? For right now. We'll do a lot more with it as we get into things. If you are curious about navigating it, I made a quick chalk talk about how we navigate Schoology right there. Any other questions? All right, let's dive in.
Are you worried that someone's like gonna join your Schoology?
Well, first off, they would have to have a paid subscription to Schoology, so I'm not really that nervous that somebody could just join it. And I get an email notification every time somebody joins my class. So, and if they join my class, I'd probably just message them and be like, yo, what are you doing? And if they're like, I just want to learn, I'd be like, okay. hang out, learn, do it. Like, I don't really care. Other people could access my Schoology, and I would not mind as long as they don't mess anything up. Would anybody have the opportunity to see Caleb? Does anyone live close to him that you would actually like go to his house and drop this off? You have a game today, so I doubt you have time. Alright, so these are Caleb's extra notes. Caleb, sorry, here's your notes. Reach through the screen and grab them like in Willy Wonka. Alright, so Calvin.
For someone to get into your Schoology, wouldn't they have to have the class code?
Yeah, but in that video, they could have paused the video and saw the class code, is what she was saying.
The class code was like.
But in email, who cares though? Like, if somebody else joins, whatever, maybe they can help us.
I'm sorry.
What if they like hacked it?
What if they what? Hacked it? I mean, if they made it better, I don't know.
They deleted
All of my stuff is saved on a resources page. So, like, the worst thing that could happen is the class, like, blows itself up and disappears, and I could just restart the whole thing. That's what the other day, there was nothing in there. The transfer of materials takes time, so that would be the only annoyance. So, trapezoids and kites, diving in, sorry, I forgot to look at our learning target. Diving in, our learning target's kind of separated into two different learning targets today because we are essentially doing 3 lessons, but coordinate geometry covers 2 of the lessons. So, what is different about trapezoids and kites compared to everything else we've done this chapter? The flowchart kind of gives it to you. Calvin?
They're not parallelograms.
They are our non-parallelogram, but yet specific relationship quadrilaterals. So what are these specific relationships between, like, what makes a kite and what makes a trapezoid as opposed to just being a quadrilateral? Yeah, Michelle?
A trapezoid has
A trapezoid has a
one set of parallel lines.
set of parallel lines that we call the bases. So when we talk about the bases of a shape in a trapezoid, the parallel sides are the bases. Go ahead.
Oh, I was going to say the two the adjacents are congruent.
So there are 2 pairs of adjacent congruent sides. Love it. So, trapezoid. Isosceles trapezoid, though. We drop down to a little bit more specific. What's it mean to be isosceles? And in case you haven't seen this, so we have scalene, isosceles, and equilateral for our triangle names. This blew me away when a student told me this. And I forget who it was. It might have been one of you guys, maybe. How many lines are identical in an S? None. There's only really one line. It's a curve. How many lines are identical in isosceles?
Oh yeah, my math teacher taught me this.
How many lines are identical in equilateral?
Wait, but what if you draw the middle line equal to the other two?
Stop, Calvin.
That wouldn't be an edge, though.
Stop.
Or, oh, this you mean?
Yeah.
Okay, they're not identical, though, because these are going the same way, right? So, if you have trouble remembering isosceles, which I doubt at this point, this is more of a 7th grade trick, but the isosceles, you have 2 that are the same. So, an isosceles trapezoid, the bases still have to be parallel and different lengths. So then the other edges that are not bases are the same. So then a kite, we just see these congruent sides and those congruent sides. What other cool relationship does a kite have that it doesn't show here? Sure, Calvin again.
Diagonals are perpendicular.
You might want to draw that in. Diagonals are perpendicular. Right like that. So let's review what makes these things what they are. In an isosceles trapezoid, if you look over at your first theorem while I'm waiting for this to capture, since we know that those edges are congruent, what else do we know? And the theorem tells it to us. Since those edges are congruent, remember that the angle is determined by the length of its opposite side. So the angle is determined by the length of its opposite side. If the opposite sides are congruent, we can actually create a proof to show this. And I think at one point we do work through this. I can make a triangle right here that uses the base and the edge and this enclosed angle. And I can make a triangle here that uses the base, the other edge that's congruent, and this enclosed angle. And actually, these diagonals are congruent to each other. So what I have is two congruent triangles by side, side, side. I have similar triangles by side, 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 but then I see that they are congruent, like the sides are congruent, so then I get congruent triangles, which makes all of those angles congruent pairs. So A is paired with R, T is paired with P. Any questions on why my base? And actually, these are called a base pair and another base pair. Base does not have to mean bottom. So this is a base and that's a base. Any questions on that? I have faces looking at me as if you already know this, which I kind of anticipated. So exactly what I said, in an isosceles trapezoid, those diagonals are congruent, which is how I can then prove those angles. And then the mid-segment of the trapezoid, regardless of if the trapezoid is isosceles or if it's a scalene, the mid-segment will be the average of the sum, well, of course it's the sum, the average of the lengths of the bases. So if you take base 1 plus base 2, divide by 2, or multiply by half, you will find that mid-segment length. Any questions on that? And if it's a kite, like we already drew in, you have perpendicular diagonals. Anything else that you guys think we need to know about these? Well, he might not be. So, we have an isosceles trapezoid. I would underline or highlight or something that. Angle C is 65. We need to figure out D, E, and F. Now, is there any other relationship in the trapezoid that we didn't talk about? It may have been notated in the theorem, but nobody brought it up. Actually, I don't think it's notated in the theorem. And I just realized that my screen captures have not been happening. Hold on, let me try to get this actually captured. There's 57. There's 58. Unless I forgot the screen capture, which I may have. So we know angle C. Carmen, what else can we kind of figure out here?
Angle C is supplementary to angle C.
How?
Because, I know this.
Because I think you called this the wrong thing the other day, so I want
Yeah,
to see if you know it
because I
now.
call it the opposite interior angle, but actually it's the alternate interior.
But wait a minute, what you just said dealt with C and D.
Sorry, no, they're like, they're vertical angles. But
They're not vertical either.
No. Wait. Okay.
Hold on.
Okay, wait. Pause. So,
The pause button.
like, if you like extended the...
Ooh, okay. I like extending lines. And then we could extend this. I don't know why that was so... So, my favorite professor ever. My favorite professor ever. And this was like mind-blowing when he finally was like, guys, all you have to do is extend the sides. Always, he would ask, can I draw a line? Can I notate something? Can I extend something? Can I, like, take something out? So the whole extending a line, I see parallel lines and I see angle relationships. So actually, Carmen was trying to say alternate interior, which I'll give you, that these alternate interior would be, what are alternate interiors? Their relationship is congruent, right? So then that can take me to the fact that this is the supplement, because if this angle has to be congruent to that angle, then it's got to be the supplement. But what you were trying to really say is same side interior.
Yeah.
If they are same side interior, they are supplementary to each other. So based off that, I know that angle D is going to be 180 minus 65. So angle D is 15. Thank you. I didn't hear the 100. All I heard was 15, so I was going to hope somebody caught it. So then, I kind of know everything, don't I?
Yeah.
Yep.
Straveler, how so?
I'm just going to say C is congruent to F because in an isosceles trapezoid, the base angles are congruent.
So, angle F also equals angle C, so that is 65 degrees. And what do I know about angle E? Emma? Yeah, angle E is congruent to angle D, so since we already found angle D, it's the same thing as angle E. Any questions on how we figure all that out? one smart word. Try the got it on your own. Oh, and whoever asked why are there 2 problem 1s and that stuff the other day, you'll notice as we get further in the notes, I only copy problem 1 and then got it. It doesn't have another 1 next to it. So I caught on to that as I was doing notes. Wasn't that you, Ethan, who was like, wait, why?
What's the thing on the board?
Oh, that was from a 7th grade review game.
That boy.
And we can play some review games throughout the year. But a lot of times you guys don't really need a review game. We'd rather just move on forward and just use the time for learning projects and things like that. So we will play review games on chapters that I think we need to review. This one is not one of those. A lot of this.
Please pardon the interruption. Josh Malinch, please come to the
Yeah,
office.
teammates.
Josh Malinch, please come to the office. Thank you.
Yeah, that's what they were telling me, but I don't know about those things. I don't have the time.
I don't know about those.
It's like them, they're Pokemon. I don't.
Memes.
Okay.
Guys, Pokemon.
You haven't seen so there's this video of this girl, and I think she works at like Home Depot or somewhere, and she's in her truck, and she's like really mad, and it's funny because she's like, so these kids kept coming into my store and trying to catch these Pokemon, and it was really annoying, so I thought if I download the game, then I can just catch all the Pokemon, and then they won't come into the store. So I downloaded the game, and I caught all these Pokemon, and that's not how it works. Like, she's like, these Pokemon are still there. So now I look like a nerd, and I'm just... Yeah, so go look for it. What do I know? Somebody new. Rhea?
P is congruent to R, so that's what
No, wait a minute. P
Oh
is...
wait, no, I mixed them up. I meant R would be congruent to S.
Ah, R will be congruent to S, so the first thing we can notate is that angle S is 106 degrees, and then...
Subtract.
Brian?
Well, then R would be supplementary to P and Q. Or P or Q.
R would be supplementary to P or Q, correct. So,
Yeah,
and
both
Q
equal
would be the supplement or the difference, which is, sorry, you said?
74.
Yeah. 74, which is also the angle of P. Any questions?
My dad found this video that's like the Pokemon Strike Back, and it's a whole bunch of guys dressed up as Pikachu's.
In that van?
Giant, like,
Yep.
Yeah.
The first guy in that video is what makes it funny.
Have you seen a frozen waffle or disco waffle
No.
disc?
No.
These
No, I
guys in their car drive down like busy streets where there's like people walking,
Yeah.
and then they just like have frozen waffles, and they just.
So my opposition with things like that are it's a waste of time, money, and food. So I don't enjoy videos like that. So the second ring of a paper fan. So anyone ever seen a paper fan? It's all folded up real nice and neat, and then you unfold it, and all of a sudden you've got the sweet fan, which luckily this year Phoenix hasn't been that bad. But some years kids have made their own paper fans, and they're not actually, they're not actually what the real paper fan used to be. Calvin, do you have a story for us or what?
No, our page is
Yeah,
blank.
they
We don't
don't
have
have
this
that.
page.
Did it copy any of your backs?
Nope.
No.
Are you kidding?
Oh, man. Oh, crikey.
Go ahead and start that worksheet, the homework for 5-6. I'll be back in a minute.
Oh, crikey.
Apparently 2 to 2-sided did not happen.
Well, we can just write it down.
Now that we have our back, if we know that this paper fan, and actually real paper fans fold all the way around to that the kind of enclosure of it is then the handle, so it meets right like perfectly in these triangles. So if we have 20 triangles, and we know that they're all, the triangles then have isosceles trapezoids in them. So this shape right here is our isosceles trapezoid. So this is find the measure of each angle at the center of the fan. So this is the measure of the vertex angle. How do you think they found that 18 degrees?
I guess.
No.
They divided it by how many squares there are.
Yeah, we know an entire rotation, an entire circle is 360, and if it's made up of 20 different vertex angles, then we can just take 360 divided by 20. So right here, you would want to write 360 divided by 20 gives us that 18 degrees. Now, from knowing that this is 18 degrees, I can then derive every other angle, including x and y. How can I derive these angles? The same, like 5 hands. Emma?
If it's an isosceles triangle, the two base angles are the same.
Yeah, two base angles have to be congruent, so their sum would be the difference between 180 and 18, which is 162. Which then, since that's the sum of both of them, yeah, 81, right? So this must be 81 degrees, which would then lead me to, well, is there another that would be 81?
Yep.
If this is a trapezoid, what do you know about this side and this side? Brian? They're parallel. So based off that, I have corresponding angles right here. Because this is one transversal. So x has to also be 81. And then y, Brian?
99.
Y has to be 99. Because it is the supplement to x. Does anyone have questions how we did that? Try the got it with now 15 interior triangles or trapezoids. And find x and y. Did you already do it?
You wrote a degree sign for x equals.
So you don't need it. I sometimes write those even when you don't have to. Because x is going to plug in and it already has the degree symbol, you don't have to put it on your x equals. I just like to so that I know I'm referring to a degree measure. Because x is not a variable in the degree measure. X is the degree measure. Brian?
X would be 78.
Okay, so first let's derive angle 1 in there. So they have a little, and you may not be able to see it well on your paper, but angle 1 is that interior angle of the whole circle. So what'd you get for that angle?
Oh,
24.
You're backing yourself up, 24. So then that led me to finding essentially x, but you first kind of do this angle right here, but it is x.
Yeah.
So you found out that x was
78.
78. Can we verify that?
Yep, I did.
Yeah. So then y is
102.
nice. Now the last thing to talk about now is our mid-segment theorem, and that I heard you guys discussing as I came back in the classroom. What do we know about QR in this image right here? What do we know about QR? Calvin?
It's the average of the lengths of LM and PN.
It's the average of the lengths of LM and PN. So if I take 4x plus 10, or sorry, minus 10, then plus 8, divide that all by 2, that's going to equal my x plus 2. So I can combine my like terms. A negative 10 plus an 8 is going to leave me with 4x minus 2 divided by 2. Well, that's really 2x minus 1. And that's going to equal x plus 2. Any questions how I've gotten to where I am right now? Ethan? Yeah, so the setup is the weird part. So I'm going to break this down a little slower. What I want to do is add up the two bases and then average it, so I divide by 2. So there's base 1 plus base 2. And then to average it, I divide by 2. Are you with me there? Base 1 up here. Base 2. Average them, I divide by how many there are, which is 2.
So you're just trying to find x.
So then, since I've averaged it, that's going to equal the x plus 2. Questions on this part?
So QR equals the average of LM and
PN, yes. So if you go back to the front of your paper on one of your trapezoid theorems, it's the trapezoid mid-segment theorem. Tells you the mid-segment of the trapezoid is the average of the bases. So add up the bases, divide by 2 since there's 2 of them. So now I combine my like terms. My negative 10 and my positive 8 are like terms since they're both constants. So that gives me 4x minus 2 when I combine those, then divided by 2. But I can divide each of those by 2 and really get 2x minus 1 for my left-hand side of the equation. So all of this is still left-hand work. Then that equals the x plus 2. Any questions? Then, if we're good at our equation solving, I take my variables to the stronger variable side, I bring my constants to the better constant side, and I get that x is equal to 3. Now I check it by saying, well, if x is 3 up here, 4 times 3, 12, minus 10, this would be 2. If x is 3 here, this would be 5. And if, well, x doesn't matter here. So if this is 2 and that's 8, sum is 10, average is 5, right there. Works out perfect. Brian?
Do we know that MR and RN are congruent?
MR and RN. Yes, because R has to be the midpoint of that edge. So this does not need to be an isosceles trapezoid, but because this is the mid-segment, Q's got to be the midpoint and R has to be the midpoint. Good question. Do you guys think you could do the got it?
I have a question. Actually, I forgot to ask this for problem 2 about it. How did you get the y?
Oh, it's the supplement to x. Because that's a trapezoid.
I know, but like, how did you get one of the like? I know they equal 180, but how did you get like one of the degrees?
So we found out that 1, we took 360, the whole circle, and divided by the 15 triangles. That gave me that angle 1 was 24, I think those guys said. Yeah? So then, if I actually look right here, what I now have is an isosceles triangle with a top angle of 24. I know that these are congruent, so these base angles have to be congruent. I know that triangle angle sum theorem, this has to be 180. So really what I have to distribute between these two angles is 156, but that has to divide to both of them. So that tells me that each one is 78.
Yeah. Okay, that makes sense.
And that is right here. So that corresponds to x and is the supplement to y. Thank you for asking. So because I did not hear a resounding yes for this one, we might as well try it. To set up it's the setup that will throw people off. You want to think about this equals half the sum of the other two sides. Ethan? Okay, so hang on to it for a second. So I'm going to set up my 2x plus 11 first, then average my other two sides. So 10 plus 8x minus 12, averaged would be divided by 2. 10 minus 12, to combine my like terms, gives me negative 2. I still have the 8x, and that's all divided by 2. My left side would copy down, so I'm going to put, you know what the double tick marks mean? That is not an 11, it's a double tick mark. It means exactly what was above it. Yeah, it's kind of like the ditto mark people will say. So that means exactly what it was. It did not change. So if this was like a standardized test, don't use that. But if it's just your notes, you can say, okay, it's exactly what was up there. It did not change. So again, my left side is not going to change. My right side becomes negative 1 plus 4x. Now I can start solving this. So I'm going to go ahead and write this side out. What would I want to do? What's the best option here? There's 4 correct options, but the best option, Carmen?
Would be to subtract 2x from both sides
Yep.
and then add 1 to both sides.
Subtract the 2x from both sides to get positive variables. Add 1 to both sides to get positive constants. So now we get 2x is equal to 12, and x would have to be 6. Right, but I ran out of space. So if x is 6, then it wants me to solve for mn. Now, I could plug in 6 here, but I want to verify the whole thing. So I'm going to plug 6 into both places. 8 times 6, 48 minus 12, 36. If I plug 6 in here, 2 times 6 plus 11 and 10. So if I added 10 and 36, I get 46. Divide by 2, I get 23. And we check it out. It works. We are good. Any preguntas? Questions in Spanish? It's one of my favorite Spanish words just because it's fun to say. Also, another fun Spanish statement is now I forgot how to say it. ¿Dónde está el agua? Mis pantalones es en flume. I think it's.
You wet your pants?
No, my pants are on fire.
Yeah,
Where is the water? My pants are on fire.
I like the joke about cats. That works in both Spanish.
Oh yeah, something about
Elliot kept telling it to me. He told me like 1,000 times. Well, not 1,000. Maybe like
gato, el
3.
gato, the cat. All right. So one of the good what?
It was a song.
Yes, I love that song.
Okay, let's keep moving on. No, I should not have even said what.
I love that song.
Since
And autumn.
since we see a perpendicular relationship between the diagonals, we really create right triangles. So since this is perpendicular, I know that angle 1, kind of obvious, has to be 90 degrees. Then from there, since I know my vertex angle or my top angle at D, what else do I know? Brian?
Angle 2,
Angle 2 has to be,
38.
yeah, the complement of the 52. So angle 2 is 38. And then angle 3, well, what else about the diagonals of a kite? We didn't talk about this, and I was waiting for us to get to here to bring it up. Straveler?
It's like an angle bisector.
Yeah, the diagonals are angle bisectors. And you know they're angle bisectors because of this perpendicular relationship. So angle 3 must be. And that is how we do all of that. Any questions on any of this? Going once, going twice. Go to the next notes. Sorry, Calvin.
So, is the diagonal between E and G an angle bisector?
Only one problem for us.
No, because so. I maybe said this too quick, and I appreciate Calvin's question. This vertical diagonal is an angle bisector because these two legs are congruent. This diagonal is not a bisector because these two legs are not congruent. That goes back to our trig. So the vertical is the bisector. The horizontal is not. Well, unless the kite's turned. But you know what I mean. So the one that hits the vertex of the congruent sides is a bisector. So down here, these two angles would be congruent also, but not these angles. So to solve that, you'd set up the right triangle again and solve for your unknown. All right, we are closing that and going to our combined 5, 7, and 8. So coordinate geometry is one of those like, let's throw variables into geometry. So it's like the merge of algebra and geometry. So square, SQRE, they think they're so clever, is a square where SQ is 2A. So I know that this span is 2A. The axes bisect each side. Okay. So if I need to figure out the coordinates, well, if the span between S and Q is 2A, what do I know about the span between S and the y-axis, or the y-axis and Q, or any? Yeah, math. It's half of it, so it must be A. And since it's a square, these are all A, which means that S would have the coordinates. What's the X and what's the Y? It's not AA. Negative A, because this is in the quadrant where my X values are negative.
You know the frowny face at first, like
Yeah. Q would be at, I'll take anybody. Just AA. It has a drinking problem. E.
I don't get it. I don't get it.
Alcoholics Anonymous. AA. It's a really good organization for people with a drinking problem because they go there and they support each other and they tell stories and things like that. So my uncle went to it a couple times. E.
Negative A, negative A.
Guys, I told you I like you. I will let you in on my life. I don't like. He had problems. It's okay. So negative A, and then R is our only one left. A, negative A. Please do not switch around your X and your Y. I was grading some Math 1 work, and like these simple mistakes of swapping your X and your Y, that's where most people fall into the trap. They work too fast, they swap around their coordinates, and they get goofed up. Any questions on that? Aside from why my smartboard will not wake up. Okay, you move on if you want. There we go. So now we have a rectangle, RECT. They think they're very clever. With height of A and length of 2B, and the y-axis bisects ECRT. So what do we know about E to the axis, or Y, or the axis to C? If the length is 2B and we know the length gets bisected, Megan? They would both be B. Ha ha ha. So, R, and now we have points that sit on the axis. R is B. Yeah, be careful which which variable we use. B is what relates to my X values. So we have negative B, 0. And we might as well jump over to T while we're on the X-axis, because that would just be the opposite, or B0. Don't be 0, be someone.
Oh, boom, savage.
E, up here, negative BA, because it is directly above my R, they will have the same X coordinate. C, directly above my T, they will have the same X coordinate. BA. Winner, yeah. So, OCBA is this, I forget exactly, it's like the Ohio, or something, it's some organization, I forget what it is. But, so we have parallelogram OCBA. What are the coordinates of D, the point of intersection of the diagonals of ABC, or they say ABCO. But so now it's a point that we don't even have. So go ahead and draw on your diagonals. And we're going to label point D here. Now, if these are my diagonals, what do I know about them? They bisect each other? They do. They're not congruent, so be careful. They are not congruent, but they do bisect each other. So I could say, like, this length will be the same as this length, and that length will be the same as that length. Yeah, Megan? What do you mean midpoint of both? Like, the midpoint of the diagonals, or what do you, like? Okay, so D is the midpoint of each diagonal length, but I don't really, I mean, I could do my distance formula. Okay, I agree, but there's an even easier way, actually. So what do you notice about this x coordinate compared to that x coordinate, or compared to that x coordinate? Okay, yeah, it's an expression using two different variables. If I extend that a little bit further, Emma? Sure, yeah.
So if this is 2B, and then that's 2A, and this is 2A plus 2B, then wouldn't this bar be 2A? No.
2A is the distance from the origin out to A.
Just a thought. So then, okay.
That was a good thought. You got to start asking questions if you're ever going to find the answer. Brian?
Wouldn't D just be 1A plus 1B, and then comma 1C?
So what we're really trying to find is its x coordinate and its y coordinate. Since we have not made it as far as I wanted to, we will just pause it here and pick this up. I don't know if we'll pick this up at all tomorrow or if we'll just let you guys roll and then wrap this all up Monday. We'll probably still just do a work day tomorrow, but I expect that we'll have questions on those next worksheets. Yeah, we're going to have work day. But like we could finish these notes in probably 15 minutes.
Wait, so Mr.
Huh?
Hudson, we're just gonna probably just finish up.
We don't have time to finish the problem, so I'm just going to leave it for
Wait,
now.
Mr. Hudson, we're probably just gonna finish the notes tomorrow and just go for the rest.
I don't know that we'll finish. If you guys want to finish these, we can. There's not a whole lot left to do. So, have a great day, guys. I'll see you tomorrow. We'll get some work done.